So, first understand what is this.
Picture a circle. Here's a center, here's point A, and here's point B. Point A is twice the distance from the center of the circle to point B. Oh yeah, and it spins from its center. In 2 seconds, both points do one full revolution. But to go all the way around, point A has to go this far, while point B only has to go this far. And we all know if something travels a greater distance in a shorter amount of time, it must be going faster. So point A must be moving faster than point B. Okay, now swap out this flat circle for the Earth, and the same thing is true. All points closer to the center, say like someone in Greenland, will be spinning slower when compared to points spinning further away from it, say like people in Brazil, closer to the equator. So if we look at it all flattened out, we can picture something like this. Arrows at the equator travel faster than arrows at the 45-degree line, like we just observed. Now imagine you're a cloud that formed here on the equator. You'll have the same velocity as the Earth, but then a gust of wind sweeps you to the north, where the Earth isn't spinning as fast. Due to inertia, your speed remains the same. You don't get any faster, but everything around you is literally traveling slower, so you, relative to the ground, move ahead of everything else. If you're a cloud that forms at the 45-degree line, you'll also have the same speed as everything around you. But if you drift down to the equator, you'll be moving slower than the ground underneath you, so you'll fall behind. And the same things for the southern hemisphere. Moving towards the equator always results in falling behind, while moving away results in pushing ahead. Okay, now imagine a low-pressure cell. That means all the air around it will get sucked into the center. But the air coming from the equator will be traveling faster, so it will deflect to the right, while the air coming from the poles will be moving slower, so they'll fall behind and deflect to the left. What this results in is a circular air current spinning counterclockwise, and that's exactly what hurricanes are, low-pressure cells spinning because of the Coriolis effect. Moving this example down to the southern hemisphere, things are reversed. A low-pressure cell will still suck in the surrounding air, but now the air coming from above will be moving faster, again deflecting to the right, while the air coming from below is moving slower, again falling behind by moving to the left. This results in a clockwise spin, which is why storms in the southern hemisphere spin this way. And that's about it. It's a short video, and that's kind of the point. I hope you got what you came for. And the Coriolis effect doesn't really influence...
Understood what is Coriolis effect? Very fast it was, but what he says that the Earth's rotational speed is greater at the equator and it is slower at the poles. And because Earth's rotational speed is greater at the equator, so cloud जो उसके ऊपर form होता है, it is having the speed of the rotational speed of the Earth. Now because it is faster, it has to go to the same distance and therefore वो right में या left में move करेगा. I will share this video with you. जब भी ये हुआ तो जो भी डाउट है कोरियोलिस इफेक्ट का थोड़ा वो फास्ट बोलता है, दैट इज़ व्हाई आई हैव टेकन दिस वीडियो, ताकि उसको जो 10 मिनट में जो चीज़ें हैं वो उसने 2 मिनट में समझा दी है. नाउ यू कैन जस्ट हैव द आइडिया, लुक एट दिस वीडियो हियर.
The image is unmistakable. Lightning is one of the most incredible natural phenomena, and one that scientists are still learning about. It's a common occurrence during
cumulonimbus
when the heat of the day is broken by strokes of lightning. Worldwide, it's estimated lightning occurs 50 to 100 times a second. The greatest concentrations of lightning strikes are in Central Africa, the Himalayas, and South America. Lightning is often seen flashing between storm clouds in the earth. The bursts of light are pure electricity. Scientists don't fully agree on what actually causes the electrical charge to be dispersed, but it is generally thought that lightning often occurs within the downdrafts and updrafts of thunderstorms. Lighter particles moving toward the top of clouds become positively charged, while heavier particles heading toward the bottom become negatively charged. When the positive and negative charges grow large enough, lightning is released between these regions. Most of the lightning takes place within the cloud, but some strikes the earth in bold flashes. In these cases, the charge escapes the cloud, making a branching path that reaches for the ground. The energy of the lightning strike contains hundreds of millions of volts and lasts only a fraction of a second. What seems to be a single flash is actually a series of return strokes of electrical energy reaching back up into the clouds. The path reaches temperatures of around 50,000 degrees Fahrenheit. This extreme heat creates the booming thunderclap as excessive pressure within the lightning path expands at supersonic rates on return strokes. In the U.S., lightning occurs most often in Florida. It's hot
So that is
climate
not required.
perfect for creating thunderclouds, which produce lightning.
But you can see all these clouds are an example of cumulonimbus cloud.
100 lives a year on
And
average in the U.S., more than hurricanes or tornadoes. During electric Africa, the Himalayas.
this photo is the photo of approaching cold front. Cold front is coming. So this is the approaching cold front precipitation. So we'll see all these photos. One small thing जो आज ही के lecture में होगा, that is the use of information technology in predicting climate and especially in disaster management. See, we are much at a behind level, but you can just imagine how weather prediction is done in the developed regions of the world. ये है weather prediction का report. They will warn the people, that is, do not go out, but in a different way कि लोग उनकी बात सुनेंगे.
Extremely dangerous Hurricane Florence continues to close in on the southeastern United States, and it will carry with it significant storm surge and life-threatening inundation. Let's look at these maps, for example, created by the National Hurricane Center to give us almost a block-by-block assessment of how much water rise you can expect above normally dry ground. This, for example, over southeastern North Carolina in Beaufort and Morehead City. These are some locations that we think will get significant storm surge. Now, these areas shaded in yellow and orange can expect water rises of 6, maybe even 9 feet. That's going to flood many of these locations downtown. But it's more than that, because this is not just going to be a coastal phenomenon. We know that the storm surge with Florence is going to continue inland and surge many miles. For example, in Newport, North Carolina, significant inundation, water rises above 9 feet nearby, and even farther west than that. This
Now you watch.
will find its way well inland. So let's now have a look at what that might be like. For example, we know Florence is going to bring 1 to 3 feet of inundation across many locations. That certainly is enough to knock you off your feet. It can definitely stall cars out and even carry cars away, and certainly flood many of the lower levels of structures. But we know Florence is also going to bring water rises well above that, perhaps up to 6 feet. Now,
So,
6 feet of water.
this is the use of technology.
That puts large objects in it. But
Wind speed is increasing as cyclone is approaching.
and enhance the damage that would otherwise be. And also, we know that could flood the lower levels of many structures. We also know that Florence is going to carry with it likely storm surge well above that, perhaps 9, 10 feet, maybe more. That will totally cover up one-story buildings and structures, leaving them underwater, and certainly pose a risk to many. There are very few places that are safe when the water rises this high. So please, follow the advice of your local officials and heed the evacuation warnings, and of course stay updated on all the latest forecasts.
So the news reporter was telling that follow the advice of the centers, local authorities. And they showed it with the help of the visualization. So you can use it in the answer on disaster management, that is the use of information technology in disaster management, the use of computer graphics in disaster management. Fine. So we'll look at some of the PPTs, and is it visible there? So what is this? This is an example of an warm front. So you can see warm air is coming and slowly rising over the cold air mass. On the ground there is a cold air mass, and as a result of this it will help in the formation of stratus clouds. So this is an example of a warm front. The air slowly rises upwards. Which air? The warm air is slowly rising upwards. How to identify warm front? By looking which clouds in the sky? Cirrus clouds. So these are the cirrus clouds in the sky. This is an approaching warm front. These are what are the cirrus and the stratus clouds in the sky. दूर से warm front ऐसे दिखेगा. Now, what will happen in the warm front? The air will rise upwards and it will give a rainfall, which will occur only for a shorter duration. Fine with this? So you can see the air is rising and nimbostratus cloud. ये बन गया stratus cloud because air is gradually rising upwards, sheet-like rising. And this is how beautiful the warm front will look like. Fibrous clouds, mare's tail. This is cirrus cloud, not this one. This is cirrocumulus. This is cirrus. Fine. Ye hai stratus. So this is the cirrus clouds. So warm front approaching cirrus clouds. You remember only this for preliminary examination. Warm front approaching cirrus clouds. What is the cold front? Cold air goes, which is more steeper? Cold front. So, जब भी steeper, which cloud it is? Cumulonimbus cloud. The cold air is coming and it is coming as a huge mass. It is vertically throwing the warm air upwards. Because the air is being vertically thrown upwards, wind वहाँ से आ रही है. As a result of this, that will result into formation of an cumulonimbus cloud. And once you know cumulonimbus cloud diagram, there is lightning and there is an heavy rainfall. So this is how a cold front will approach. Reality में कैसे दिखेगा cold front approaching? This is how the cold front approaching will look like. Warm air is being uplifted. So this is what is the cumulonimbus cloud, an approaching cold front. Yeah, this is an approaching cold front. This is how the cumulonimbus clouds are seen. Obviously, this part will get huge amount of rainfall. What is an occluded front? Only cold air on the ground. So this is an occluded front. इसलिए diagram triangle है. So चाहे it is warm front or cold front, ultimately there will be cold air on the ground and there will be warm air upwards. क्योंकि formation of front. So cloud development because of frontal lifting of warm moist air, advancing very cold air, receding cold air. Receding cold air मतलब जो नीचे है. And this is how was the advancing. This is an example of an cold front. This is an example of an warm front. So we combine these two and we say it is an occluded front. What is a stationary front? Stationary front, both the winds are flowing parallel to each other. So actually it is not a formation of front because front matlab slopes. Then what do you mean by tornado? When a very high velocity air is being thrown upwards, generally associated with cold fronts, where the warm air is violently thrown upwards. So how does the tornado look like? This is an example of a tornado. यहाँ से you can see cumulonimbus cloud. So this is cold front, this is warm air, this is cold air, and देखो warm air को ऐसे ऊपर फेंका जा रहा है. It cannot go to this side because this is cold. So you see this is an example of an tornado. The most dangerous of all atmospheric disturbance. ये क्या है? This is air which is going upwards at the speed of somewhere around 700 to 900 kilometers per hour. This is a low pressure center. बाकी सारी जगह से winds will be pulled in this low pressure center and it will be thrown upwards. Because they are vertically thrown upwards, it will result into formation of cumulonimbus cloud, lightning, thunder. Why tornadoes are so dangerous? Because tornadoes will always occur in groups. The tornadoes will always occur in groups on the flat land. Can you see? This is a flat land. So tornadoes will always occur in groups. So how cold front and tornado is formed? This is how a tornado forming has started. That is, this is how the cumulonimbus cloud forming has started. So cold air violently uplifting the warm air, the common in USA. But what if tornado-like conditions develop on the water body? We call it as water spout. So this is an example of an water spout. क्या हो रहा है? समंदर का पानी ऊपर फेंका जा रहा है. A low pressure is created and the water is being thrown upwards. So this is one example of a water spout. Or you can see this is another example of a water spout. This is a ship, container ship. If it goes somehow there, so obviously it will be thrown upwards. So this is an example of a water spout here. Getting it? Everyone? What is this temperate cyclone? We have done this yesterday. The stages in the formation of temperate cyclone. सबसे पहले stationary front, then the cold air. ये cold front है and warm air here. So the cold air tries to enter in the territory of warm air and the warm air is trying to enter in the territory of an cold air. Circular movement of air has started. A rotational circulation has started. Then the cold air is attracted towards the warm air, and the warm air ka area is slightly reducing. So isliye pressure difference has started in this region. Ultimately, this has developed into a proper cyclone when the warm air is trapped in between. Baki, it is totally surrounded by the cold air. After that, see how the cold front is advancing. Cold front means which is in blue color, which is shown by triangle. The cold front is advancing, and as the cold front advances, ultimately there will be no cold air on the ground, and this is what is known as an occluded front. And then again there will be end of an cyclone. Fine? But this is all about the temperate cyclone. What about this tropical cyclones? Tropical cyclones are totally different. The green color lines are the lines of tropical cyclones. The black color lines are the lines of temperate cyclones. You can see temperate cyclones southern hemisphere में तो proper उसी जगह है. They are associated with very cold air, right? So उसी जगह है. But northern hemisphere में because of Himalayas winds नहीं जा रही है, so ये पूरा cold है. This entire region is cold. यहाँ पे mountains है, glaciers है. इसलिए the temperate cyclones also originate over Mediterranean Sea, Black Sea, Caspian Sea. Can you see this? Then they will come to India. Why? Jet streams. And after coming to India, they will give rainfall during the winter season. Temperate cyclones कब originate होते हैं? During the winters. And we call this as western disturbances. So western disturbances क्या है? Western disturbances westerlies है, western disturbances jet streams है, या western disturbances temperate cyclones है? They are rainfall caused due to temperate cyclone. कौन लाता है उनको? Westerlies. Westerlies को कौन लाता है? Sub tropical westerly jet stream. So western disturbance is only rainfall. It is brought in India by subtropical westerly jet stream. इसके ऊपर there is a jet stream which is flowing. So you can see ये जो बारिश यहाँ की हो रही है, that is western disturbances. या ये यहाँ के पानी से जो snowfall हो रहा है, this is western disturbances. Otherwise there is no source of moisture except Mediterranean Sea, Black Sea and the Caspian Sea region. Getting it? Otherwise this is a temperate cyclone. Now this is a tropical cyclone. यहाँ पे they are known as cyclones. यहाँ पे they are known as hurricanes. यहाँ पे they are known as willy-willies. And sorry, यहाँ पे they are known as typhoons. And यहाँ पे they are known as hurricanes. Now in this diagram itself, have you noticed one thing? That is, there are no temperate cyclones at the same latitude on the western coast of the continents. On the western coast of the continents. Except for India, ज़्यादा नहीं है western coast of the continents में. So there are temperate cyclones only on the eastern coast of the continents, or tropical cyclones only on the eastern coast. India में दोनों जगह है, Arabian Sea and Bay of Bengal में. यहाँ पे only again on the eastern coast, but not on the western coast. Only on the eastern coast, not that stronger on the western coast. Arrow is ending here, and यहाँ पे तो totally absent है. Can someone tell me why? ITCZ क्या है? You will be surprised to know California desert, Atacama desert, Namib and Kalahari desert, Sahara desert, Great Australian desert, ये पूरा the Great Australian desert. सारे desert एक ही latitudes में. So we know what latitudes are this? Horse latitudes. All these deserts are in more or less the same latitudes. Horse latitudes. Caused due to submergence of air, high pressure. So cyclone is high pressure or low pressure? Cyclone is low pressure. So जहाँ जहाँ deserts है, we do not have temperate we do not have cyclones. So why we have deserts? तीन conditions है. One, they are located in the subtropical high pressure belt. ठीक है. Second, trade winds are offshore. This is the belt of trade winds. Equator से offshore trade winds. Thirdly, जो हम oceanography में करते हैं, they are washed by cold currents. ये एक cold current है. ये एक cold current है. यहाँ पे also there is one cold current, cold ocean current. यहाँ पे also there is a cold ocean current. यहाँ पे also there is a cold ocean current. So cyclones के लिए Tropical cyclones के लिए you require heat or cold water? Heat. So wherever we have cold currents, we do not have tropical cyclones. Then why only in Indian Ocean, north में? Because you can see North Indian Ocean is the only ocean in the world which is not connected to the cold water of Arctic. Southern Indian Ocean is connected, इसलिए नहीं है. But जहाँ Arctic का पानी नहीं है, there is no connection. We have tropical cyclones on both the sides. But wherever the oceans are open, there is absence of tropical cyclones because cold currents will originate here. Due to Coriolis force, they will be deflected to the right और यहाँ पे आएंगे. Cold currents will be originate. Cold water due to Coriolis force will be deflected to the left and it will come here. It will get deflected to the left and it will come here. So tropical cyclones do not originate in the regions where there are cold ocean currents because heat is required for tropical cyclone. And this small area is what is known as Mediterranean type of climate. ये पूरा region, Northern California, surrounding the Mediterranean Sea, and then this region is the Mediterranean type of climate. This entire region is the Mediterranean type of climate. क्यों? कभी trade winds during the normal, and when the trade winds shift down, then they come under the westerlies. पहले they are under the trade wind belt, summers में. ये सारा line ऊपर चली जाएगी due to shifting of IDCZ. So trade winds are offshore. But when the trade winds shift down, that is when they come here, winters में. Trade winds अब कहाँ originate हो रही है? Over Himalayas. So they come under the influence of westerlies, onshore. But British type of climate, continuously westerlies. Hot winds pick up moisture, hit North America. Cross known as Chinook. Cross known as fawn. Getting this? So, and then we have the next thing, that is how does the करता है गुजरात साइक्लोन ओखी लास्ट ईयर इन द एंड साइक्लोन विंड ये सब में कौन सा व्हाट विल डिटरमाइन? जो स्ट्रॉन्गर है वो रेजिस्ट करेगा. ट्रेड विंड इतनी स्ट्रांग है, ट्रॉपिकल साइक्लोन्स की विंड स्ट्रांग है. सो बट कभी कभी हिट करेगा. इज इट हिटिंग? विच स्टेट? गुजरात. Gujarat is the only state which can be hit by a tropical cyclone. Not necessarily, कभी भी आ सकता है. Now, first temperate cyclone. So how do we look at the temperate cyclone? Fronts, cold front भी है, warm front भी है. कल मैंने final diagram बनाया. So this is how the temperate cyclone will look like. So this entire part is what is known as a temperate cyclone. This entire part is a temperate cyclone. So temperate cyclone, can I say, is a very, very vast phenomena. That is, the distance of a temperate cyclone is somewhere around 3,000 kilometers. 3,000 kilometers bada phenomena is known as a temperate cyclone. Means you can say UP can also be under the influence of temperate cyclone, and Pakistan mein also there can be a temperate cyclone at the same time. Tropical cyclone itna bada nahi hai, thankfully. Otherwise it would have been a natural disaster. And जितने stronger natural disaster है उतने वो छोटे हैं. You saw how much small was the tornado. So this is a temperate cyclone. So temperate cyclone, cold warm front precipitation, stratus clouds, rainfall. First this is a region of cold air. क्या है? यही जो मैंने कल diagram बनाया था. It has been opened up. This is the region of cold air. After that we have the warm sector, and then we have the cold front. Cold front is associated with cumulonimbus cloud, lightning and thunder, and this is what is the temperate cyclone. On other hand, what is a tropical cyclone? Extreme weather phenomena. So this is a tropical cyclone, and due to Coriolis force कौन से direction में है? Anti-clockwise. You can see the winds are moving in anti-clockwise direction. इतना stronger low pressure center है. Look at this animation very properly. इतना stronger low pressure center है that winds from here also are pulled in this low pressure center. Getting it? And then they go in anti-clockwise manner, and then it is moving anti-clockwise manner in this due to Coriolis effect. Getting it? But can you see, as soon as it is reaching the land, it is dying. Why? Concept of latent heat of vaporization, moist heat. It requires moist heat to survive. Fine with this? And the last is regarding we have already done this, that is the clouds. Stratus, stratocumulus, cumulus, nimbostratus, altostratus, altocumulus, cirrostratus, cirrus, cirrocumulus, and then we have cumulonimbus cloud. Getting this? So just an idea, ये वैसे कुछ काम का नहीं है diagram, but to just get the things cleared. Now what do you mean by jet streams? Strong upper air circulation. कहाँ पे develop होगा? जहाँ पे there is a maximum difference of temperature between two air masses. So between the tropical cell, will it develop? No. So will the jet stream develop over ITCZ? No. Will it develop between the tropical cell and the feral cell? Yes. That is what we call as subtropical westerly jet stream. Will it develop between polar cell and the feral cell? Yes. That is a polar front jet stream. And this is what the jet stream is. ITCZ से the air will rise upwards. It should actually go and settle over the pole. But वो इतनी heavy जाती है कि it comes and settles back between 30 to 35 degree north, and it flows back as trade winds. So this is a Hadley cell. Now यहाँ पे height ज़्यादा है, so this is more colder as compared to this part. And hence wind starts flowing from here to here, but it gets deflected to the right, and ये बन जाती है subtropical westerly jet. Or it gets deflected to the left in southern hemisphere. दोनों का direction becomes west to east and बन जाती है subtropical westerly jet. Now this air after rising comes here, but you have just seen now यहाँ पे क्या है? Fronts. So because it is fronts, air is forced to go up. As this air is forced to go up, it is warmer air and this is extremely cold air. So maximum difference, इसलिए jet stream stronger भी है. And this is the polar jet stream. Fine with this? How do they look in the real life? They look somewhat like this. So this is a polar jet, this is a subtropical jet, and it flows circumpolar, that is all over the globe in a very fast manner. So एक UPSC ने क्वेश्चन पूछा था, jet streams are generated due to the rotation of the earth. True or false? It is nothing to do with the rotation of the earth. Rotation of the earth एक factor है, एक factor, but most important factor is difference between the temperature of an air mass. So this is the polar jet, this is the subtropical westerly jet जो इंडिया के ऊपर भी आएगा, but wherever there is ITCZ there is no jet stream, क्योंकि air mass same है. There cannot be jet streams over ITCZ. Secondly, इसीलिए when during the monsoon, when the ITCZ will shift to India, what will disappear is this jet stream will disappear. How does it look in satellite image? This is how the jet stream is flowing. Subtropical westerly jet stream, and देखो satellite image generally NASA के है, इसलिए they will be US centric. So this is a polar jet stream, this is subtropical westerly jet stream. So it will take cold maritime air masses and give rainfall in Canada. Therefore jet streams will influence the air in this, and we have taiga biome here, boreal biome. Getting it? Narrow region, but do they move in a straight manner? No, they move in a meandering manner. क्यों? क्योंकि यहाँ से warm air is trying to go inside and यहाँ पे the cold air is trying to come inside. इसलिए fronts are being developed. So this is how our global circulation is. Surface winds, trade winds, westerlies, and उसके ऊपर is the jet streams. Fine with this? And if you want to have a real life look at from the satellite, this is an example of an jet stream. This is how the jet stream is moving. Satellite जब भी photo निकालेगा, it will depend upon the thermal property. So temperature से photos के colors change हो जाएंगे. So as a result of this, jet streams. This is what is an aerial photography. This is jet stream. This are some isobars, isotherms, pressure belts. और ऐसे दिखेगा world हमारा. So this jet stream is flowing over here. Fine with this? And lastly, thunderstorm. Again, mechanism वही है, heating of an air. So this is how the thunderstorm is developing. You can see air हम ऐसे बनाते हैं, but air, I told you, always goes upwards in a spiraling manner. Thunderstorm, it will cause heavy rainfall and it will cause lightning also. So this is how the thunderstorm has developed. You can see the air is being low pressure, say air is being lifted upwards. And then lastly, what I said you, metallic rods over the buildings so that the electricity is being directly grounded. Understood what is the concept of Coriolis, what is the concept of winds? में तो कोई doubt नहीं था, but what are jet streams? Right, west to east. So now we will continue with the temperate cyclones. Temperate cyclones. बहुत ज़्यादा लाइट और वीडियो दिखता नहीं है. Fine with this? Understood this diagram अभी? So this is a mixture of cold front and warm front. कौन सा diagram है ये? वही circular diagram which we have opened up. Fine? So structure of temperate cyclone. So the structure of temperate cyclone. कल ही बनाया था हमने ये diagram. तो structure of a temperate cyclone. The temperate cyclone consists of sectors of different temperature, sectors of different temperature, sectors of different temperature, sectors of different temperature. Due to convergence of warm and cold air. Due to the convergence of warm and cold air. Due to the convergence of warm and cold air. So you understand this is a warm sector, this is a cold sector. It has warm and cold air. Next. The temperate cyclones can be around 3,000 kilometers in diameter. 3,000 kilometers in diameter. 3,000 kilometers in diameter. Third, different parts of temperate cyclone, temperate cyclone has different weather conditions, different parts of a temperate cyclone has different weather conditions. And rainfall or precipitation occurs only along the fronts. Rainfall or precipitation occurs only along the fronts. Rainfall or precipitation occurs only along the fronts. The cold front precipitation is heavy along with lightning and thunder, but of shorter duration. Self understood है सब ये points. Cold front precipitation, while the warm front precipitation is gentle but for a longer duration due to the presence of nimbostratus clouds. After their origin, the temperate cyclones move from west to east under the influence of jet streams and westerlies. Weather conditions. कैसा होगा weather condition? To understand the weather condition, this is how a temperate cyclone has developed. उसके बाद it is going to move from west to east. Maybe jet stream is going to carry it. So to understand the weather condition, what you will have to do? You will have to just place yourself here. आप पहले खड़े हो, आपको कौन से clouds देखेंगे high up in the sky? Cirrus clouds. फिर the temperate cyclone is going to come near you. So initially the temperature will decrease. Will there be rainfall? No rainfall. This is a cold air का sector क्योंकि temperate cyclone ऐसा आ रहा है. Then after that you come into this region, temperature increases. Third point ऐसा आएगा because of the arrival of which front? Warm front. What will be the weather? There will be drizzle, gentle precipitation for a longer duration. After that, rainfall के बाद temperature is going to increase. Why temperature is going to increase? Because we come in the warm air sector. Then suddenly there will be decrease in the temperature. That shows the arrival of cold front. The weather will deteriorate and there will be heavy lightning, thunder, snowfall या rainfall depending upon what latitude you are. And उसके बाद again the weather will become stable. There will be clear and cloudless skies, but the temperature is going to drop. और ऐसे temperate cyclone निकल जाएगा. Getting this, everyone? So even in the examination you do not remember the lines. अगर ये diagram याद रखा और खुद को प्लेस किया इस जगह, दैट इज द आंसर. खुद को एक बार वार्म सेक्टर, कोल्ड सेक्टर में प्लेस करना है, फिर वार्म फ्रंट में प्लेस करना है, फिर वार्म एयर में सेक्टर में प्लेस करना है, फिर कोल्ड फ्रंट में प्लेस करना है, एंड फिर कोल्ड एयर सेक्टर में प्लेस करना है. एंड यू हैव टू राइट द आंसर्स. यहाँ पे ऑलरेडी यू नो हैवी रेनफॉल, यहाँ पे यू नो जेंटल रेनफॉल. गेटिंग दिस एवरीवन? क्लियर? So, is there space here? So, you can take down. I'll give in very, very short points. An arriving temperate cyclone, an arriving temperate cyclone, arriving temperate cyclone is determined by the presence of cirrus clouds in the sky. Is determined by the presence of cirrus clouds in the sky. Cirrus clouds in the sky. Second point. With the arrival of cold sector, with the arrival of cold sector, temperature decreases. Temperature decreases, but it is marked by, but there is a presence of clear weather and atmospheric stability. Clear weather and atmospheric stability. Third, and atmospheric stability. Third, with the arrival of warm front, temperature increases, and there is gentle precipitation. There is gentle precipitation due to the presence of cumulonimbus clouds in the sky. Nimbostratus clouds in the sky. There is a presence of nimbostratus clouds in the sky. Nimbostratus clouds in the sky. Next point. Temperature increases. Low pressure systems are developed. But the sky is cloudless and clear. क्यों? कहाँ पे हैं हम? वार्म सेक्टर. उसके बाद कोल्ड फ्रंट. With the arrival of cold front, fine with this. Description की ज़रूरत नहीं है. I guess you are able to follow. हमने इतने डिटेल में किया है ये तो. With the arrival of cold front, weather conditions deteriorate. And there is heavy precipitation. From cumulonimbus clouds. And last, arrival of cold sector. Is marked by sudden decrease in the temperature, with cloudless and clear skies. marked by sudden decrease in the temperature with cloudless and clear skies. Fine. So एक दो दिन से ये जो कोल्ड वेव है, कोल्ड वेव कंडीशंस है, either it can be normal onset of winters that we cannot predict, or either you are in this position. After some days there will be light rainfall. उसके बाद गर्मी बढ़ेगी, and then one day there will be so heavy rainfall कि उसके बाद फिर से एक और cold wave आएगा, because we will come in this sector. So this we are right now in the temperate climatic conditions, temperate cyclone का conditions. ये temperate cyclone का we are in the cold sector right now. But इतने धीरे से जाएगा ये, unlike tropical cyclone. It is an atmospheric natural disaster. ये normal weather condition है. Fine. So one last statement. Temperate cyclones cause rainfall in North India, Pakistan, which is known as Western disturbances. Fine with this? Rainfall is western disturbances, phenomena is temperate cyclone, bringing bodies are westerlies and subtropical westerly jet stream. Getting it? So actually western disturbance क्या है? Westerly winds? नहीं, it is precipitation. So any one of you have experienced tropical cyclone? Nobody from Orissa? You have been there when it was live? मतलब जब tropical cyclone था तब थे वहाँ पे? So what are the weather conditions?
Very much rainy and windy.
It is having very very high velocity winds. अभी हमने देखा लो प्रेशर सेंटर इज सो इंटेंसिफाइड, उस एनिमेशन में भी था कि व्हेन द लो प्रेशर सेंटर इज देयर, विंड्स आर सक्ड इनटू दिस लो प्रेशर सेंटर एंड द विंड्स आर थ्रोन अपवर्ड्स. सेकंड, वो इतना ज्यादा डेंजरस है ट्रॉपिकल साइक्लोन कि दे आर नोन बाय डिफरेंट नेम्स. दैट इज वी ऑलरेडी नो द नेम्स. इट इज नोन एज साइक्लोन्स इन विच ओशन? इंडियन ओशन. इन द कैरिबियन सी व्हाट इज द नेम? कैरिबियन सी कहाँ पे है? यूएसए के पास. सो इन यूएसए हरिकेन, कैरिबियन सी हरिकेन, वेस्ट इंडीज हरिकेन. इट इज नोन एज हरिकेन्स विच डेवलप इन द अटलांटिक ओशन रीजन. इट इज नोन एज टाइफून्स इन साउथ चाइना सी. तो साउथ चाइना सी में से समटाइम्स इट गोज इवन अप टू जापान. इट इज नोन एज विली विली ऑस्ट्रेलिया. एंड उसके बाद इनको डिफरेंट नाम देने के बाद उनको प्रॉपर नाम है. It can be called as Gaza, it can be called as Katrina, it can be called as Florence, it can be called as, what is Katrina? The most dangerous hurricane ever recorded. 2 साल पहले. It was causing death of 900 people on a single day in a developed nation such as USA. डेवलप नेशन में 900 डेथ्स अगर होता है तो उतना सीवियर एटमॉस्फेरिक डिस्टर्बेंस अगर अपने जैसे डेवलपिंग कंट्री में आएगा तो यू जस्ट इमेजिन द डेथ.
What is the phenomena behind the giving the names of?
We will come to that names also. So this is what is known as a tropical cyclone. So उनको एक तो प्रॉपर नाम भी है and they are having regional names also. So remember the regional names for prelims. एक जनरल क्वेश्चन, रिमेंबर प्रॉपर नाम कौन सी कंट्री देती है. सो इस साल जो जो साइक्लोन्स इंडिया में आए, सो विच आर द कंट्रीज दैट हैव गिवन द प्रॉपर नेम्स. सो गाजा वाज गिवन बाय श्रीलंका, बांग्लादेश. साइक्लोन ओखी वाज गिवन बाय बांग्लादेश. पिछले साल था, इतना इंपॉर्टेंट नहीं है. गाजा वाज गिवन बाय श्रीलंका और फेताई इज गिवन बाय थाईलैंड. सो ये भी पता होना चाहिए. Understanding? Now what is this cyclone? What is the speed of a temperate cyclone? 30 kilometers per hour. But tropical cyclone is known, अगर आपने न्यूज़पेपर पढ़ा होगा रेगुलरली, तो a depression has originated in Bay of Bengal. Government is watching the depression. ऐसे word आता है, depression has originated in the Bay of Bengal. Tropical cyclone is known as a depression if the wind speed is less than 60 kilometers per hour. It is known as a cyclone only if the wind speed crosses 72 miles per hour or 120 kilometers per hour. And it is known as super cyclone if wind speed crosses 300 kilometers per hour. So depression मतलब a low pressure center has developed. And low pressure center जो जब develop हुआ, if the conditions are all right, then it can mature in the tropical cyclone. Depression will get matured into cyclone, and cyclone may get matured into the super cyclone. The cyclones will develop only in the late summer season when there is enough of latent heat of condensation which is available and there is enough of a low pressure. So tropical cyclones के लिए low pressure की ज़रूरत है या नहीं है, या किसी भी cyclone के लिए? So tropical cyclones are associated with ITCZ. When ITCZ is not at its original position, which is the original position of ITCZ? Equator. When it is away from its original position, see tropical cyclones is very conceptual. So एक word important है, कुछ भी doubt है तो पूछो. When the tropical cyclone is not at ITCZ, that is not at equator, when it is away from the equator, Coriolis force has higher values, and because the Coriolis force has higher values, it will cause deflection of the wind around the low pressure center, and due to this deflection of the wind around the low pressure center, the air will be thrown upwards, resulting into development of tropical cyclone. समझ में आया या नहीं? This low pressure center has to be fed by moist heat which is coming from the latent heat of condensation. मतलब आपको कुछ तो समझ में आ रहा होगा कि ITCZ ऊपर होना चाहिए, कोरियोलिस फोर्स होना चाहिए और लेटेंट हीट ऑफ कंडेंसेशन होना चाहिए. इतना समझ में आया? सो बस उतनी ही की ही ज़रूरत है हमें अभी, एज ऑफ नाउ. So what is the mechanism behind it? So first we will take down the definition of a tropical cyclone. Tropical cyclones are most dangerous atmospheric disturbances that develop in the tropical oceans and seas, associated with release of moist heat and higher value of Coriolis force, due to convergence of warm air masses. Read the definition again. This is the actual technical definition. जो हमारे बुक्स में है, बहुत सिंपलिस्टिक वर्जन है इसका. अगर ये रिप्रोड्यूस कर पाते हो एग्जाम में तो बेस्ट होगा. इसमें आपने सब कुछ डेफिनेशन में बता दिया कि इसमें इसको लैटेंट हीट ऑफ कंडेंसेशन चाहिए, इसको कोरियोलिस फोर्स चाहिए, एंड इट इज़ फॉर्म ड्यू टू कन्वर्जेंस ऑफ एयर मासेस. सो कन्वर्जेंस ऑफ वार्म एयर मासेस कौन से जोन पे हो रहा है? ITCZ. सो वो इम्प्लाइड है डेफिनेशन में कि इट विल डेवलप नियर द ITCZ एंड ऑन द वाटर बॉडीज. फाइन. सो आगे का आंसर ऑफ अ ट्रॉपिकल साइक्लोन इज इसका एक्सपांशन. एक एक पॉइंट को एक्सपांड करके बता दिया. बट इफ यू कैनॉट रिमेंबर, सो जस्ट रिमेंबर इट, दे आर वन ऑफ द most dangerous of atmospheric disturbances that originate on the warm oceans, full stop. They are caused due to heating of the oceans above 27 degrees Celsius, full stop. Due to heating of the oceans, low pressure center develops, which causes convergence of different air masses, full stop. After the convergence of air masses over the low pressure center, air rises upwards, releases the latent heat of condensation and causes tropical cyclone. But answer इतना बड़ा हो जाता है. Understanding this? So try to remember this definition. They are known by different names. They are known by different names. Such as cyclones in the Indian Ocean region. Cyclones in the Indian Ocean region. Cyclones in Indian Ocean region. Second, hurricanes. Hurricanes in, see, coastal USA around Florida. अभी जो मैंने दिखाया था वो फ्लोरिडा का ही न्यूज़ रिपोर्ट था कि कहाँ तक अंदर जा सकता है पानी. एक वर्ड अगर आपने बार बार सुना होगा तो दे वर टॉकिंग अबाउट स्टॉर्म सर्ज. हैव यू हर्ड दैट वर्ड इन द वीडियो? इन द गल्फ ऑफ मैक्सिको, and the Caribbean Sea region. In the Gulf of Mexico and the Caribbean Sea region. So किसी में भी कोई भी एक MCQ आता है इसमें, उस पूरे रीजन को क्या नाम है? The hurricanes. ब्राज़ील में भी क्या नाम है? नॉर्थ ब्राज़ील में hurricanes. Understanding this? So ये मत सोचो ब्राज़ील में कुछ अलग नाम होगा. That entire region is हरिकेन्स. इंडिया में एंटायर रीजन चाहे मालदीव्स में आता है चाहे मैडागास्कर में, और वेदर इन इंडिया द नेम इज साइक्लोन्स. दे आर नोन एज टाइफून्स इन साउथ चाइना सी. दे आर नोन एज typhoon in Japan. कोई ज़्यादा फर्क नहीं है. Typhoons and typhoon, and they are known as Willy in Australia. क्या? ऑस्ट्रेलिया, क्योंकि ट्रॉपिकल साइक्लोन्स आते ही है ईस्टर्न ऑस्ट्रेलिया में. वेस्ट ऑस्ट्रेलिया में अभी वही देखा कि हम वो आ नहीं सकते, साउथ में आ नहीं सकते. सो ऐसा थोड़ी है कि सिर्फ उड़ीसा में उसको साइक्लोन कहा जाता है, पूरे इंडिया में उसको साइक्लोन कहते हैं. तो सेम थिंग यू आर गोइंग टू राइट हियर. यूएसए का क्यों हमने अलग लिखा? क्योंकि यूएसए इतना बड़ा है कि इट हैज़ टेम्परेट एज वेल एज ट्रॉपिकल साइक्लोन्स. USA has blizzard also. You see, USA is much bigger than India. USA has both long, bigger north-south extent also. USA का एक पार्ट इक्वेटर के पास है, दूसरा पोल्स के पास है, अलास्का. So USA is a very big country. इसलिए उसको इसमें हम we have to be specific कौन से रीजन में. ऑस्ट्रेलिया, इंडिया में ऐसा थोड़ी है कि सिर्फ ओडिशा, आंध्रा में उसका नाम साइक्लोन्स है, दिल्ली में उसका नाम कुछ और है. सो ऑस्ट्रेलिया इज ऑस्ट्रेलिया. पर अगर क्वेश्चन पूछते स्पेसिफिकली तो वो एक अलग है. कौन सा पार्ट ऑफ ऑस्ट्रेलिया एक्सपीरियंसेस ट्रॉपिकल साइक्लोन? देन योर आंसर विल बी ईस्टर्न, नॉर्थ ईस्टर्न ऑस्ट्रेलिया. नॉट जस्ट ईस्टर्न, नॉर्थ ईस्टर्न ऑस्ट्रेलिया. ईस्टर्न ऑस्ट्रेलिया इज एंटायर टिल मेलबर्न, सिडनी. सो वी विल राइट दैट एनीवेज बाद में. सो यू कैन फाइंड We'll come to that. Due to their high destructive potential, they are also given proper names. Can someone tell me why proper names?
If they want to market something so that they can give the name of that particular thing.
क्योंकि ट्रॉपिकल साइक्लोन डिजास्टर मैनेजमेंट करना पड़ता है. डिजास्टर मैनेजमेंट में नेम अगर है तो इट इज स्पेसिफिक. फॉर एग्जांपल, इफ आई कॉल हिम ए एंड इफ आई कॉल हिम आल्सो ए डैश, इफ हम सबको नाम नहीं होते तो ये भी ह्यूमन बीइंग, यू आर ऑल्सो ऑल ह्यूमन बीइंग. सो ह्यूमन बीइंग हु इज सिटेड इन द थर्ड रो वेयरिंग ब्राउन कलर का जैकेट, लिसन टू मी, वो डिफिकल्ट हो जाता है. सो उससे अच्छा डायरेक्ट नाम दे दो. सो यू रिमेंबर इट इज़ फॉर नेचुरल डिजास्टर, सो दैट अर्ली वार्निंग सिग्नल्स आर प्रॉपरली गिवन. बिकॉज ट्रॉपिकल साइक्लोन्स आपने वो डायग्राम में देखा होगा, उसका कोई डायरेक्शन नहीं, ईस्ट की तरफ तो जा रहा है, कभी ऊपर कभी नीचे, कभी गुजरात की तरफ. फॉर एग्जाम्पल ये क्या था, ऐसे लग रहा था फिताई आएगा तमिलनाडु में, चला गया आंध्रा में. सो दे यू कैनॉट ट्रैक दिस बिकॉज इट इज एन हाई एनर्जी सिस्टम. एंड जो भी हाई एनर्जी सिस्टम है, आवर नॉलेज इज लिमिटेड बिकॉज वी कैनॉट गो एंड स्टडी दिस हाई एनर्जी सिस्टम. पहले था जाने वाला था तमिलनाडु में, तमिलनाडु वॉज प्रिपेयर्ड, फिर प्रेडिक्ट किया कि इट इज गोइंग इन ओडिशा, ओडिशा ने पूरा डिजास्टर मैनेजमेंट कर दिया और गया वो आंध्रा में. मीन्स एज इफ ही न्यू कि ओडिशा इज रेडी एंड तमिलनाडु इज रेडी, तो मुझे वहां पे कोई मिलेगा नहीं, सो आई एम गोइंग इन टू आंध्र प्रदेश. सो दैट इज वॉट इज द ट्रॉपिकल साइक्लोन. Last time Okhi, while going, hit Kerala. Kerala से जाके it went and stuck in Gujarat. So that is what is a tropical cyclone. So उससे नाम is very very easy, and नाम is easy because आप न्यूज़ में वही पढ़ते हो which are coming to India. But in the month of December itself, I told you, in the month of November, more than 40 tropical cyclones originate only in the Bay of Bengal. 20 more originate in the Arabian Sea. सो टोटल इंडिया हैज, अगर सच्ची में डिजास्टर मैनेजमेंट करना है तो इंडिया इज अंडर द थ्रेट ऑफ 60 ट्रॉपिकल साइक्लोन्स ओनली इन द मंथ ऑफ नवंबर, 80 ट्रॉपिकल साइक्लोन्स इन द मंथ ऑफ अक्टूबर. थैंकफुली सारे इंडिया में आते नहीं है, ओनली 1 or 2 एंड इन रीच हियर बिकॉज आते आते दे डाई आउट, they cool because of rainfall and they die out. But in the entire Indian Ocean there are numerous storms originating. So you can take down the next statement and prepare it for this year's prelims. ये statement जो मैं दे रहा हूँ. The tropical cyclones are known as depressions when their wind speed is around 68 kilometers per hour. 68 kilometers per hour. 60 to 68, मैं एग्जैक्ट दे रहा हूँ 68 किलोमीटर्स, वैसे यू कैन रिमेंबर अराउंड 60 किलोमीटर्स पर आवर, आर नोन एज साइक्लोनिक स्टॉर्म. If the wind speed is between 60 to 120 kilometers per hour, cyclonic storm, when the wind speed is between 60 to 120 kilometers per hour, 120 kilometers per hour, and they are known as cyclones. If the wind speed crosses 120 kilometers per hour. Wind speed crosses 120 kilometers per hour. ठीक है? इसके बाद का conditions, area, it should be by heart. In the manner I am telling you, because इसमें से I'll just tell you some of the past year questions and they will check your conceptual knowledge in this. So each and every condition should be by heart. Mechanism तो चलो समझ में आ जाएगा. The condition should be very properly understood. Land. Fine. And then we have ocean water. ये है कॉन्टिनेंटल शेल्फ वाला रीजन. सो वी हैव एन ओशन वाटर. Initially, anywhere low pressure center can develop. It can develop here, it can develop here. So hundreds of such low pressure centers develop in the Bay of Bengal and the Arabian Sea. But we'll take, for example, a low pressure center has developed here. As the low pressure center has developed here, it will attract the winds from the surrounding regions towards the low pressure center. Now, is this very hot? Yes. Low pressure center means this part of Bay of Bengal or the Arabian Sea or any ocean will become warmer. And it is over the ocean, so evaporation भी बहुत ज़्यादा है. And because the evaporation is greater, it will release large amount of heat which will be captured by the surrounding air. Fine? Now, as it comes to the low pressure center, this air will be forced to rise up. When the air is forced to rise up, condensation will start occurring here. As the condensation will start occurring here, जो अंदर की heat in the air, it will be given to the surrounding region. Is that heat powerful? Yes, because it is moist heat. What is that heat known as? Latent heat of vaporization or latent heat of condensation. So when the latent heat is added to the surrounding atmosphere, low pressure center intensifies. As the low pressure center intensifies, winds from the far away region will be attracted towards the low pressure center. Or if the winds from the far away region will get attracted towards the low pressure center at the speed of 60 kilometers per hour, National Disaster Management Authority will start tracking it. Because ये कभी भी cyclone बन सकता है and then it can go in any direction. Means you should know the National Disaster Management Authority is continuously tracking the ocean region कि in this climate कि कब cyclones बन रहे कब नहीं बन रहे. So in this region the winds from the surrounding region will be pulled here. And this low pressure center is so intense that winds before reaching the center will start vertically rising upwards. When they start vertically rising upwards, self-feeding mechanism hai. Again, the low pressure center is getting intensified. जितना ज़्यादा वो wind को pull करेगा, उतना greater the low pressure center is going to get intensified. Why? Because moist heat is being released in the atmosphere. And ultimately, these winds will come with such a great speed, it is known as cyclone or super cyclone, and all the winds will go upwards before reaching this low pressure center, because it has intensified, area has increased. When the winds go upwards, it is rotating with such a great speed that the winds will be thrown in different directions. This you already know कि ऊपर जाके winds will bifurcate and the winds will be thrown in different directions. Due to this, a huge wall of cumulonimbus cloud is formed. It will result into the formation of condensation हो रहा है, जहाँ जहाँ condensation होगा, there will be formation of a huge wall of an cumulonimbus cloud. There will be formation of a huge wall, on the other side there will be formation of huge wall of an cumulonimbus cloud. After that, there will be numerous such another walls of the cumulonimbus clouds. क्योंकि winds तो आ रही है over the period of time, and as a result of this, such numerous cumulonimbus clouds will be formed. आपने देखा layers में air घूम रही है, and then this system, when it matures, this system is what is known as a tropical cyclone. So the tropical cyclone has two important features. One important feature is a huge wall which will go right up to tropopause of a cumulonimbus cloud, and this is known as an wall. Inner wall, outer wall, ऐसे 100 walls of the cumulonimbus cloud होगा. हमें सिर्फ एक wall अगर GS में बनाए तो भी it's enough. So this is another wall of an cumulonimbus cloud. While the center part, आपने hole देखा होगा in that animation, that center part which is very very small is known as an eye of a tropical cyclone, and the surrounding huge wall of a cumulonimbus cloud is known as an eye wall or wall of a tropical cyclone. So ऊपर जाके, because the winds are diverging on the other sides, we call कि the tropical cyclone has ground low pressure, while up में there is an high pressure center. High pressure मतलब divergence. Ground में there is an low pressure center. So air ऊपर जाएगी and it will be thrown upwards. जितना air ऊपर thrown होगी उतना it will act like an exhaust fan कि नीचे की और उतनी air it will pull upwards, and as a result of this it will be a mechanism. जैसे ही wall of the cumulonimbus cloud बनेगा, this entire part will start giving very very heavy rainfall. What we will call this as an cloud burst. So there will be very heavy rainfall along the wall of a cumulonimbus clouds. Plus there will be winds 120, 300, 350 kilometers per hour. But tropical cyclone की एक सबसे important characteristics है that each and every part of a tropical cyclone will give rainfall except for a small center, rainless, cloudless center, which is known as an eye wall. Eye of a tropical cyclone, arc. So what is the characteristics of an eye? It has low pressure, and in spite of low pressure, it does not have any clouds up. And it is a rainless, cloudless center. And the second important thing about the tropical cyclone is, due to this ground low pressure center, यहाँ पे pressure इतना कम है कि the sea will rise upwards, and there will be very high amount of sea waves which are generated. Pressure कम हो गया, so water का level बढ़ गया. And after their origin, as the tropical cyclones will travel towards the land, the waves will also travel towards the land, and this very strong waves which rise in the sea are known as storm surge. जिससे you have just seen coastal flooding होता है, and the water level can rise up to 9 feet, 10 feet, etc. So the storm surge, it is not wind, it is not rainfall, which is the most dangerous part of the tropical cyclone. The most dangerous part of a tropical cyclone is storm surge. So in Orissa, we have recorded the storm surge having a height of 35 feet. 35 feet का strong waves are coming and destroying the entire, जब super cyclone आया था in 1999. So the Orissa में we had a 35 feet का. Obviously when ocean water is slapping anything with great speed, slapping मतलब ऐसे आके वो गिरेगा, it will destroy everything. But storm surge is most dangerous because ocean water will enter the cities, it will enter the land inside, and it will cover the agricultural fields, making the soil saline and unproductive for next 3 years, minimum 3 years. क्योंकि salinity बढ़ जाएगी of the soil, and is saline soil good? No. And therefore we say कि economic losses etc. are caused due to the tropical cyclone. During the cyclone, super cyclone Falin in Orissa, again, Falin in Orissa, what was the wind speed? The maximum wind speed was recorded at 650 kilometers per hour in super cyclone Falin. But till the time it reached Orissa, wind speed had decreased. But we have a lone survivor of a tropical cyclone. A fisherman in Orissa. Have you heard about him? So he was pulled up in the tropical cyclone when he was doing fishing, क्योंकि उसने सुना नहीं था, don't go out for fishing. He was taken up and thrown 35 kilometers inside. 35 kilometers inside. And thankfully, he landed on a haystack and he survived. He landed on a haystack and he survived. So one of the person who can tell you what is this, that is, I want to tell you what is this cyclone is. टेम्परेट साइक्लोन में आपको कभी कोल्ड फ्रंट ऐसा ऊपर नहीं ले जाएगा. इसमें इफ यू थिंक चलो यू आर गोइंग टू सर्वाइव, नाउ ये कैसे आएगा? इट इज गोइंग टू कम टुवर्ड्स द ईस्ट. सो फॉर अंडरस्टैंडिंग द वेदर कंडीशंस ऑफ अ ट्रॉपिकल साइक्लोन एग्जैक्टली उल्टा सोचो. प्लेस योर सेल्फ हियर, then there will be very heavy rainfall, the winds will drag you inside, and after dragging inside they may throw. When the winds are very very strong, they throw the objects, houses, trees, etc. for a longer distance, and they are known as cyclone missiles. Cyclone missiles कुछ तो coming and hitting you, but thankfully India में इतने cyclone missiles नहीं है. USA में tornado missiles बहुत ज़्यादा है. Tornado missiles, dead people, dead animals, trees, houses, which are thrown at a distance, and they can come and land on anyone. So if you survive all this, then there will be rainless, cloudless center, and you will thank God कि बच गए. You will see sunshine, etc. But maximum duration for what a rainless, cloudless center can exist is 15 minutes. I will be there only for 15 minutes. बाकी का phenomena will be for 3 days. इट इज़ वेरी स्मॉल, आपने देखा होगा एनिमेशन में. एंड उसके बाद आप फिर से नहीं बचोगे क्योंकि नाउ द विंड इज कमिंग फ्रॉम अपोजिट डायरेक्शन. एंड देयरफॉर वी से दैट द ट्रॉपिकल साइक्लोन्स आर वेरी वास्ट. ऐसा नहीं कि यहाँ से अगर यहाँ पे आए तो विंड बाहर फेंक देगी. नो, अगेन चांसेस आर अप, और अगेन द रेनलेस क्लाउडलेस सेंटर. लास्ट थिंग अबाउट द ट्रॉपिकल साइक्लोन, दिस एंटायर फिनोमेना व्हेन इट कम्स नियर द कोस्ट, उसका द सोर्स ऑफ मॉइस्ट हीट इज कट डाउन. And as soon as this eye touches the land, not this part, as soon as the eye touches the land, tropical cyclones die. But in the coastal states like Andhra, Orissa, eye को touch होने के लिए this entire part has to be inland. If this entire part has to be inland, rainfall, heavy clouds, cloud burst, and storm surge. When the eye will touch the land, sea water will go inside, and especially जहाँ पे delta है, mouth of a river है, like गोदावरी, कृष्णा, तो river के water को रोक देगा and sea water will go inside, causing flooding. This is more intensified in the cities because जो excess sea water which is coming inside due to buildings, due to roads, due to narrow bylanes, height of a water और ज़्यादा बढ़ जाता है. What is the difference between urban floods and normal floods? अर्बन फ्लड्स में इवन इफ देयर इज लेस रेनफॉल, ज़्यादा फ्लडिंग हो सकती है बिकॉज पानी को जाने के लिए जगह ही नहीं है. सो एज अ रिजल्ट ऑफ दिस वाटर बिकम स्टैग्नेंट एंड वाटर का लेवल बहुत ज़्यादा राइज होता है. इन द नॉर्मल फ्लड्स वाटर का लेवल राइज होगा बट इट विल कैरी यू अगेन विद दैट. कोस्टल फ्लड्स में इट वोंट कैरी यू, इट विल रिमेन स्टैग्नेंट ओवर देयर एंड कॉजिंग रास्ते बंद, इकोनॉमिक एक्टिविटी बंद, एवरीथिंग क्लोज्ड. This is the normal phenomena in India because of increasing urbanization and destruction of mangroves or destruction of coastal regions. because पानी को जाने के लिए जगह ही नहीं है क्योंकि इतना बड़ा पानी ये छोटे नालों में से नहीं निकलेगा. Understanding? Now, गुड़गांव is one city जहाँ पे वो लोग नाला कंस्ट्रक्ट करना ही भूल गए. That is an fault of an engineer कि they designed the city so properly, सब कुछ बना दिया, but I don't know what was he thinking कि उसने drainage system ही नहीं डाला city में. वो भूल गए कि there has to be a drainage system in the city. So Gurgaon does not have a drainage system, and इसलिए even if there is a slight amount of rainfall like Delhi, Gurgaon becomes flooded, traffic jam. So because city does not have a drainage system, those who designed the city उन्होंने सोचा ही नहीं कि उनको drainage system लगेगा. So such a basic mistake. और होता है कभी-कभी मिस्टेक्स, बट ऐसे नहीं होना चाहिए कि पूरे सिटी में एक एरिया में ड्रेनेज सिस्टम नहीं डाला, वी कैन अंडरस्टैंड, बट पूरे सिटी में ड्रेनेज सिस्टम नहीं. इसलिए सो एज अ रिजल्ट ऑफ दिस you can understand storm surge will cause more urban flooding. So now you understand what can be the questions. Questions can be cyclone disaster management. There can be a short note on what do you understand by storm surge. Storm surge पे separate question आ सकता है. There can be a question on mechanism of tropical cyclone. There can be a question on identify the cyclone prone regions of India. There can be a question on why the eastern coast of India is more prone to tropical cyclones as compared to the western coast of India. Temperate cyclones पे western disturbance खत्म हो गया question. Fine. And the last question which has come twice in your GS is compare between tropical and temperate cyclones. Getting this? ये होते ही हमारा climate खत्म. So this is the last part of climatology. Coastal flood means जो coastal regions में आएगा. Normal flood कहीं पे भी आ सकता है. If coastal flood comes in villages, it is a normal flood. If it comes in Mumbai or Thiruvananthapuram or Cochin, it is an urban flood. So, नहीं. Tsunami, earthquake, undersea earthquake, oceans, but height दोनों की same रहेगी. Fine with this? Tide से कभी tsunami नहीं हुआ. What? Northern hemisphere? Anti-clockwise. Southern hemisphere? Clockwise. वो तो हमने लिखा है शायद. वो तो किसी भी साइक्लोन के लिए it is true. Understood? So, have you drawn the diagram? Now, for making the diagram, choice is yours. ये बनाना है तो या फिर नहीं. So, अगर ये बनाया है तो लिखना. या इवन इफ यू मेक अ सिंगल डायग्राम ऑफ वन आई वॉल तो भी ठीक है. ज़रूरी नहीं कि दोनों आई वॉल दिखानी है. दैट इज इवन दिस डायग्राम इज राइट. किसका? मैं भी भूल गया. ही इज अ नॉर्मल फिशरमैन इन because he survived, so otherwise most of them people don't survive. He experienced the tropical. Can I continue? Water sprout, tornadoes. Storm surge, totally different. Storm surge is associated only with tropical cyclone. Air is forced to diverge. High pressure मतलब divergence, low pressure मतलब convergence. Converge होके ऊपर जाएगी. मिडल कोई नहीं. नो प्रेशर सिस्टम. So, can I give conditions for the formation of tropical cyclone? Conditions for the formation of tropical cyclone. First condition. They develop in the regions of warm sea surface temperature. Warm sea surface temperature. Warm sea surface temperature. Having warm sea surface temperature, having temperature greater than 27 degrees Celsius. Temperature greater than 27 degree Celsius. See, इसलिए अंडरस्टैंड, जहाँ जहाँ क्यूमुलोनिम्बस क्लाउड है वहाँ पे कन्वेक्शन है, एंड जो कन्वेक्शन है वो नेचुरल डिजास्टर है. कन्वेक्शन अगर नीचे होता है अर्थ के नीचे, वॉल्केनोज. कन्वेक्शन अगर ऊपर होता है अर्थ के ऊपर तो थंडर स्टॉर्म्स, डस्ट स्टॉर्म्स, टॉर्नेडोज, ट्रॉपिकल साइक्लोन्स. सो हीट is dangerous. Heat is a system of energy. So excess of energy जहाँ है it becomes violent. Fine. Next. It requires higher value of Coriolis force. It requires higher value of Coriolis force. And therefore, tropical cyclones do not originate between tropical cyclones do not originate between 5 degree north and south. 5 degree north and south. मतलब in the equatorial regions, क्योंकि Coriolis force is absent. So Coriolis force नहीं है तो what is not there? Deflection is not there. Third, the latent heat of condensation is the source of energy or driving engine of tropical cyclones. Source of energy or the driving engine of tropical cyclones. Hence, tropical cyclones only originate on oceans and seas. Only originate on the oceans and seas, where there is abundant moist heat. Full stop. They die when the eye touches the land. When the eye touches the land. When the eye touches the land. When the eye touches the land, it has a technical word जो आपने न्यूज़पेपर में पढ़ा है, and that technical word is known as landfall. The tropical cyclone is expected to make landfall in Visakhapatnam on such and such day. मतलब eye is expected to touch the land. And tropical cyclone touches the land. क्यों? क्योंकि the source of moist heat is cut off. Next point. They are associated with, the tropical cyclones are associated with ITCZ. Associated with ITCZ. Because in the regions of ITCZ, there is a convergence of several warm air masses. Understand? Therefore, when the ITCZ is away from the equator, bracket में लिखना, September, October, November, December. September, October, November, December. Tropical cyclones originate. Tropical cyclones originate. अगर सिर्फ हॉट होता सी सरफेस टेम्परेचर, दे शुड हैव ओरिजिनेटेड इन अप्रैल एंड मे, जब बट तब ITCZ कहाँ पे है? ओवर द इक्वेटर ओनली. ITCZ थोड़ा नॉर्थ में आता है इंडिया की तरफ. जून में गर्मी बहुत ज़्यादा है, बट ITCZ इज ओवर द लैंड. सो जब रिट्रीटिंग मानसून होता है, व्हेन देयर इज अ सफिशिएंट हीटिंग ऑफ द वाटर, प्लस ITCZ भी रिट्रीटिंग मानसून, मतलब अक्टूबर में वेयर इज द सन? कहीं तो पेनिनसुलर इंडिया के पास. दैट इज सन की मैक्सिमम हीटिंग. सन तो एक्चुअली साउथ में है, बट सन ऊपर लाइट बल्ब की तरह है. ऐसा नहीं कि लाइट सिर्फ इसी लाइन में गिर रहा है. सो इफ दिस इज इक्वेटर, लाइट इज स्प्रेडिंग. सो सन का हीटिंग इज स्प्रेडिंग, एंड देयरफॉर ट्रॉपिकल साइक्लोन्स विल डेवलप टू नॉर्थ एंड साउथ. गेटिंग इट? ITCZ इज अ वाइड बैंड. नहीं समझ में आया? इन द मंथ ऑफ अक्टूबर, सन इज इन द सदर्न हेमिस्फीयर. फिर ट्रॉपिकल साइक्लोन्स व्हाई डू दे डेवलप इन इंडिया? बिकॉज सन की हीटिंग ज़्यादा है. अब इमेजिन करो ये सन, ये ट्यूबलाइट है. सो ये ट्यूबलाइट क्या सिर्फ इस टेबल यहाँ पे नीचे वर्टिकल लाइट दे रहा है? नो. तो दिस इज सन. सन का हीट इज स्प्रेडिंग, एंड देयरफॉर ITCZ इज वाइडर. गेटिंग इट? ITCZ मतलब क्या है? हॉटेस्ट रीजन ऑफ द वर्ल्ड, जहाँ पे सबसे ज़्यादा लो प्रेशर है. इमेजिनरी लाइन. सो सन दो इट इज इन द नदर्न हेमिस्फीयर, बट स्टिल उसका हीट इज सीन इन पेनिनसुलर इंडिया. स्टिल उसका हीट इज सीन. ऐसा थोड़ी है कि सन अभी सदर्न हेमिस्फीयर में तो हमारे यहाँ अंधेरा है. सन इज लाइक अ लाइट, इट विल स्प्रेड. द ओनली थिंग इज अवे यू आर फ्रॉम दिस ट्यूबलाइट, उतना लाइट कम हो जाएगा. सो अवे यू आर फ्रॉम द सन, उतना हीटिंग विल डिक्रीज. बट अक्टूबर में व्हेन द सन इज नियर द इक्वेटर, ऑब्वियसली केरला इज ऑल्सो नियर द इक्वेटर, Tamil Nadu is near the equator, therefore tropical cyclones will develop. Now one more statement.
So, but then the ITCZ in northern hemisphere, then the chances of tropical cyclone should be more.
Yes, तो है ही. बट तब तक वाटर टेक्स टाइम टू गेट हीटेड. तब तक जब जून में हमारी लैंड बहुत हीट है, बट वाटर इज कंपैरेटिवली कूलर. सो ITCZ does not shift in the regions of cold ocean currents. ITCZ does not shift in the regions of cold ocean currents, and therefore tropical cyclones are absent. On the western coast of South America. मैंने आपको दिखाया था. कॉमा अफ्रीका एंड ऑस्ट्रेलिया. Next condition. There should be a presence of anticyclonic condition. Anticyclonic condition or high pressure in the upper atmosphere. क्यों? अगर हाई प्रेशर नहीं रहा तो क्या होगा? If this wind is going upward, there is only low pressure. Wind is going upwards. अगर हाई प्रेशर नहीं है, मतलब डाइवर्जेंस नहीं है, तो विंड विल गेट एक्यूमुलेटेड हियर. The wind will get acclimated here, it will start falling down or giving rainfall. Understanding? अगर ये wind ऊपर गई और यहाँ से फेंकी नहीं गई, so it will get accumulated here. So if it gets accumulated here, it will stop the wind from ascending. So वो बन जाएगा thunderstorm जैसा normal phenomena, आंधी जैसा. Because this air will become heavy, it will try to settle down. As it tries to settle down, तो it will not cross tropical cyclone. यहाँ क्या हो रहा है? जो भी हवा ऊपर जा रही है, it is being thrown away. So और ज़्यादा vacuum create हो रहा है. So more air is being pulled upwards and it is being thrown away. So therefore we say high pressure is necessary. Thunderstorms में ये नहीं है, इसलिए thunderstorms आधे घंटे में मर जाते हैं. जैसे ही air becomes heavy over there, बारिश बंद. आधा घंटा बहुत बारिश देगी, आंधी. बट ट्रॉपिकल साइक्लोन 4-5 दिन एयर विल गो अप, थ्रोन अवे, एयर विल बी गोइंग अप, थ्रोन अवे. इसलिए ट्रॉपिकल साइक्लोन स्ट्राइक्स ओडिशा, बट रेनफॉल होता है दिल्ली में थोड़ा बहुत. और कोल्ड क्लाइमेट कम्स इन दिल्ली बिकॉज व्हाट हैपेंस, सपोज दिस इज ओडिशा एंड दिस इज दिल्ली हियर, दिस दिल्ली विच हैज कम, द ट्रॉपिकल साइक्लोन, this air which is thrown away, has it become colder because it has gone up? So because it is colder, it will be thrown and ऊपर जाके it will become heavy and it will descend at some. So इसलिए जब tropical cyclone came in Orissa, Kerala, etc., अक्टूबर में यहाँ पे कुछ दिन ठंड हुआ था. If you remember, ये नहीं याद. So that is an cold air comes and settles down. So हम कहते हैं कि साइक्लोन के कारण यहाँ बारिश हो रही है, साइक्लोन के कारण यहाँ ठंडी ज़्यादा हो गई. अब कहाँ है साइक्लोन? उड़ीसा में, आंध्रा में. सो फार अवे इज़ दिल्ली. बट यू शुड नो कि दिस इज़ वेरी वेरी इंपॉर्टेंट पॉइंट. सो यू शुड स्ट्रेस ऑन दिस पॉइंट कि वन ऑफ द चीफ कंडीशन इज अपर एयर हाई प्रेशर. हाई प्रेशर मतलब ऐसा नहीं कि सिर्फ एयर इज कमिंग डाउन. इट ऑल्सो मीन्स इन ज्योग्राफी डाइवर्जेंस. लो प्रेशर मीन्स convergence. Air will converge, go up. Air will diverge, subtropical, high pressure belt. Air diverges. Fine? So there has to be divergence. If there is no divergence, then tropical cyclone develop ही नहीं होगा. Because suppose if there is no high pressure, so यहाँ पे cold air will get accumulated. After getting accumulated, it will start coming down. Getting this, everyone? ट्रॉपिकल साइक्लोन में होगा, हमेशा होगा. जितना एयर ऊपर फास्ट जाएगी उतना. ये किस चीज़ पे डिपेंड करेगा ये पता नहीं है. हमें सिर्फ कंडीशंस क्या होनी चाहिए पता है. रिमेंबर व्हाट आई सेड, ट्रॉपिकल साइक्लोन्स, टॉर्नेडोज, लाइटनिंग, इसके बारे में प्रॉपर स्टडीज हैव नॉट बीन डन. हमें सिर्फ पता है ये कंडीशन होनी चाहिए. क्यों होनी चाहिए, इसके लिए someone has to go there and study. So वो साइंटिस्ट नहीं था, वो जोग्राफर नहीं था, he was a fisherman. So हाँ, किसका? जितना स्ट्रॉन्गर है लो प्रेशर उतना स्ट्रॉन्गर विल बी द साइक्लोन. मतलब साथ में क्यों लो प्रेशर? बॉडी किसके बॉडी पे? अच्छा, यू आर टॉकिंग अबाउट फिशरमैन. इतना ज्यादा लो प्रेशर नहीं होता कि टॉर्नेडो जैसा. हैव यू सीन द मूवी लाइफ ऑफ पाई? इन दैट लाइफ ऑफ पाई प्रॉपर ट्रॉपिकल साइक्लोन इज शोन. ही गेट स्टक इन द ट्रॉपिकल साइक्लोन. उसके बाद 5-6 मिनट के लिए सनशाइन दिखाई है, 2-3 मिनट के लिए, व्हेन ही सेज दैट ही हैज सीन गॉड. एंड उसके बाद फिर से द ट्रॉपिकल साइक्लोन का लेटर पार्ट कम्स. सो द मूवी लाइफ ऑफ पाई हॉलीवुड मूवी है, साइंटिफिकली दिखाया है उन्होंने. ऐसे नहीं कि हमारा हीरो जाके ट्रॉपिकल साइक्लोन से ही फाइट कर रहा है. सो दे हैव शोन बिकॉज व्हेन द टाइगर कम्स टू ईट हिम, अचानक फिशेस आर थ्रोन. व्हाई? ट्रॉपिकल साइक्लोन अराइव्स. उसके बाद जब उनको ट्रॉपिकल साइक्लोन बिकम्स इंटेंसिफाइज, सडनली उसको सन दिखता है, दैट इज आई, क्लाउडलेस, रेनलेस सेंटर. फिर से, और तब तक टाइगर अटैक नहीं करेगा क्योंकि उनके जो बोट है वो पूरा फिश से भरी हुई हो जाए. फिर से ट्रॉपिकल साइक्लोन आता है, और फिर जब ट्रॉपिकल साइक्लोन आता है तो वो उनके बोट को ले जाता है ऑन एन इमेजिनरी आइलैंड जो दिखाया है. सो दैट इज व्हाट द सीन आई एम सेइंग, दैट इज व्हाट इज एन प्रॉपर डिस्क्रिप्शन ऑफ आई, रेनलेस, क्लाउडलेस सेंटर. इतना ज़्यादा लो प्रेशर नहीं है कि इट इज़ गोइंग टू रिमूव एवरीथिंग। सदर्न हेमिस्फीयर, अब तो प्रॉपरली इन द सदर्न एंड। सन एक लाइन पे ITCZ 10 डिग्री नॉर्थ टू 10 डिग्री साउथ, मतलब 1100 किलोमीटर वाला रीजन। फाइन विद दिस, सो यू कैन टेक डाउन नेक्स्ट पॉइंट, स्ट्रक्चर ऑफ अ ट्रॉपिकल साइक्लोन। स्ट्रक्चर ऑफ अ ट्रॉपिकल साइक्लोन, the average diameter of a tropical cyclone, the average diameter of a tropical cyclone varies from 30 to 300 kilometers. Varies from 30 to 300 kilometers. 30 to 300 kilometers. Understand difference के लिए points. वो कितना है 3000, ये 30 किलोमीटर, 30 to 300 kilometers. But उसका its height is around 15 kilometers from the sea level. Around 15 kilometers from the sea level. Height is around 15 kilometers from the sea level. Yes. Yes, वही है। हाँ तो हाई प्रेशर होगा ही, वही मैं कह रहा हूँ। नेक्स्ट, at the center of a tropical cyclone, at the center of a tropical cyclone is a low pressure zone, is a low pressure zone, full stop. This, underline the words rainless, rainless, no rain, rainless, comma, cloudless, cloudless center is known as an eye of a cyclone. This rainless, cloudless center is known as an eye of a cyclone. One more point. Due to the above high pressure, air descends in the region of eye. Air descends in the region of eye. बहुत weak winds जो है वो थोड़ी बहुत यहाँ से नीचे आएगी in the region of eye. So air descends in the region of eye. ये बहुत controversial है, कुछ books ने लिखा है descend करती है, कुछ books में नहीं लिखा है, but you should remember ये high pressure से slight air is descending. अगर air descend नहीं करती तो यहाँ पे clouds होते, but this is rainless, cloudless center. Clouds क्यों नहीं है? You already know. Wherever the air descends, there is no cloud. Fine. So there is, बाकी के जगह लो प्रेशर जहां से एयर इज ओवर गोइंग अप, बट आई के अंदर एयर इज डिसेंडिंग. नेक्स्ट पॉइंट, सराउंडिंग द आई is the huge wall of cumulonimbus cloud. Huge wall of cumulonimbus cloud. Known as eye wall. Known as eye wall. Third point, known as eye wall. Wall and eye wall. Eye wall is also sometimes known as wall only. तो दोनों words right है. The most dangerous phenomena of tropical cyclones are storm surges. are storm surges. Storm surges. Tropical cyclone are storm surges. Surge मतलब increase. These are developed due to extreme low pressure. These are developed due to extreme low pressure, which causes the sea to rise, sea level to rise, full stop. This strong waves travel with great speed along with the cyclone, causing coastal flooding, erosion of coastal lands, erosion of coastal lands, and submergence of fertile agricultural lands. ब्रैकेट में देखो, मैं लिखा सब रहा हूं, बट ये लिखना एज पर द डिमांड ऑफ द क्वेश्चन. अगर ट्रॉपिकल साइक्लोन का है, सिर्फ लिखो स्टॉर्म सर्ज क्या है, उसका क्या इंपैक्ट है, वो सब नहीं लिखने की जरूरत. सो इन द रिसेंट ईयर्स the intensity of tropical cyclones are increasing. Due to increase in sea surface temperature, increasing sea surface temperature, and the coastal flooding is causing more loss of life and property. Coastal flooding is causing more loss of life and property due to destruction of mangroves, unplanned urbanization, and illegal reclamation of the land. Illegal reclamation of the land. Or you can just write reclamation of the land also. Legal भी हो सकता है, illegal भी हो सकता है. What do you mean by illegal reclamation of the land?
Sensitive areas which are not supposed to be habitable.
How was Bombay constructed? There were 7 different islands located far away. उस islands के अंदर मिट्टी डाली गई, उसके ऊपर फिर एक पूरी city बनाई गई. That is constructing a city which is made up of 7 different islands. Today if you go to Bombay, you will not see any of an island, but it was filled up. It was 7 different islands located far away. So जो regions were of high tide and low tide, first cement blocks were thrown. Cement blocks से sea level was blocked, then the wall was constructed, and then उसके ऊपर the sand etc. fill करके, then the entire city was constructed by Britishers. This is what is known as reclamation. You are claiming from the nature. Or Second example, Tarai region. Forest है, you destroy the entire forest और वहाँ पे farming कर लेते हैं. So this is also known as reclamation. So when now you are reclaiming anything, you are stopping the sea in between. When you stop the sea in between, waves are coming with great speed and hitting the sea with great speed. पहले दूर तक जब waves आते थे उनकी speed used to reduce. Now the waves are coming with great speed and hitting it. अब whenever there is a monsoon का heavy rainfall, strong wind या floods, waves का speed increases and वो अपनी पुरानी जगह जाने की कोशिश करते हैं. So they will go in the inside. So example Kerala floods. Example Kerala floods. Mangroves को destroy करो, this is going to happen. Urbanization करो, the Kerala floods will now be a regular intensity. जैसे 2005 के बाद Mumbai floods are regular. Getting it?
Mangroves कैसे stop करेंगे?
I will come to that later on. Fine? Next. After their origin, they travel from east to west. They travel from east to west. But their paths are constantly changing. Their paths are constantly changing. General path है east to west, but east to west वो suppose this is our India. East to west, this is the general path, but east to west they will curve to the north, they will go straight, yeah, they will curve too much, we do not know. But they will generally move from east to west direction, but generally they go curve to the north. Understanding? Therefore we say their paths are constantly changing. You can see, पहले predict किया तमिलनाडु, फिर लगा ओडिशा, constantly change the path. क्यों? क्योंकि high energy system है. Any high energy system will not have a path. You take a top and pull it on the land. When you put it on the land, top घूमेगा and जब speed कम होगी तो curve कर लेगा. So this is what is the tropical cyclone. It is more like a top only, high energy system which is rotating with great speed. They generally curve to the north. They curve to the north, full stop. Therefore, the eastern coast of India is more prone to tropical cyclones. Therefore, eastern coast of India is more prone to the tropical cyclones. Because the tropical cyclones which originate in Andaman Sea and the Bay of Bengal, Andaman Sea and Bay of Bengal, Andaman Sea and the Bay of Bengal hit the eastern coast, while the tropical cyclones which originate in Arabian Sea move away from the western coast. क्योंकि उनका direction is east to west. Move away from the western coast. So you can draw this diagram.
जब वो नॉर्थ की तरफ रिफ्लेक्ट होते हैं तो उसमें कुछ कोरियालिस का कुछ रोल होता है?
No.
Move away from
The western coast. ड्रॉ द डायग्राम एज आई हैव शोन. स्ट्रेट लाइन नहीं है, आंध्रा में थोड़ा अंदर जा रहा है. कैन यू सी? सो इट हैज टू बी दैट वे. अरेबियन सी के पास कोई भी साइक्लोन आया तो इट विल गो एंड हिट ईरान, ओमान, पाकिस्तान, नॉट इंडिया. ईस्ट टू वेस्ट. दैट इज व्हाई इट विल नॉट गो टू मुंबई. इफ ए ट्रॉपिकल साइक्लोन डेवलप्स हियर, कहाँ जाएगा? ईस्ट टू वेस्ट.
नहीं सर, जो यहाँ से ओरिजिनेट होके जा रहा है.
इतना ट्रैवल कर ही नहीं सकता. यहाँ से ओरिजिनेट होके ऐसे नहीं जाएगा, वो रिकर्व करेगा. क्या? वेस्ट कोस्ट को नहीं हिट करेगा जनरली, अनलेस ओखी जैसा रिकर्व किया तो. वेस्टर्न कोस्ट से ओरिजिन भी हुआ तो वो ईस्ट टू वेस्ट जा रहा है, पर थोड़ा नॉर्थ की तरफ घूम रहा है, सो इसलिए गुजरात को हिट करेगा. यू सी, गुजरात इज शेडेड, नॉट महाराष्ट्र, नॉट कर्नाटका. बहुत ही एक्सेप्शन है वो, जो पिछले साल हुआ था, ओखी हुआ था वो. बिकॉज इट इज कर्विंग. दैट ओरिजिनेटेड इन अंडमान सी. वो ऐसे गया अंडमान सी, सो इट इज गोइंग टू द बे ऑफ बंगाल. अगर ओरिजिनेट करता तो जाता, रुक जाता यहाँ पे, बिकॉज इट ओरिजिनेटेड इन द अंडमान सी, इट ट्रैवल्ड, और वो नॉर्थ की तरफ ऐसे जाते जाते इट वेंट हियर. इट कैन हिट मुंबई ऑल्सो, बट इट इज नॉट दैट मच प्रोन. आई रिमेंबर लास्ट ईयर इंजीनियरिंग की एग्ज़ाम थी, मेरा प्रिपरेशन था नहीं. देयर वॉज अ साइक्लोन का वार्निंग कि इट विल बी साइक्लोन, सो हम सब खुश थे. स्टडी लीव में हमने फिर वो पढ़ाई नहीं की, क्योंकि 100% साइक्लोन आने वाला है और एग्ज़ाम्स कैंसिल होने वाली है. बट ना साइक्लोन आया और ना ही एग्ज़ाम कैंसिल हुई. सो और वो साइक्लोन आया नहीं, इसलिए मार्क्स कम आए और इसलिए यूपीएससी करनी पड़ी. सो सी हाउ, अगर वो साइक्लोन आता तो मार्क्स भी आ जाते एंड फिर अभी कहीं यूएस में जाके सेटल हो गए होते. सो इंजीनियर जीआरई देख. सो एक साइक्लोन ने डायरेक्शन चेंज नहीं किया था. अर्थक्वेक भी आया भुज में तो 26 जनवरी को आया, उसका भी कोई फ़ायदा नहीं हुआ. सो ऑलरेडी हॉलीडे था, एक दिन दूसरे दिन कॉलेज चालू ही था फिर. अंडरस्टूड दिस? नाउ व्हाई केरला? शेप टेपरिंग इतना है कि इट कैन, उसका इफेक्ट कैन बी इजीली सीन इन केरला. अंडरस्टैंडिंग? Fine with this? So that is all about the tropical cyclones. Andaman and Nicobar, will they hit? Not that much, क्योंकि equatorial regions में. So they are not that prone. Andaman and Nicobar is more prone to tsunami, not to the tropical cyclone. Can I rub this part? Now, can someone tell me why is this? This is what I wanted to ask. In the अंदर क्यों है? Open the map of India, the first map of India, first page, physical map, page number 10, page number 10, page number 10, physical map. The intensity is greater. See, Andhra में it goes much deeper. इसीलिए 48 deaths अभी भी. So Andhra में it goes much deeper because of two reasons. One, if you see Western Ghats, ये है Western Ghats, fine. These are Eastern Ghats. So you'll find Shevarai. उसके find ऊपर you'll find Javadi. मिला कि नहीं? So you'll find Shevarai. You will find Javadi Hills. उसके बाद यू विल फाइंड पालकोंडा, ये सारा ईस्टर्न घाट्स है. उसके बाद यू विल फाइंड नल्लामलाई, मिला दिस 4. सो याद रखना शिवराय, जावाड़ी, द पालकोंडा, नल्लामलाई, एंड उसके बाद गैप है टोटल, एंड गैप के बाद डायरेक्टली ओडिशा में गरजात है. नाउ व्हाई इज दिस गैप? This gap is because you have one of the biggest delta in this region formed by Godavari and formed by river Krishna. So because of river Godavari and Krishna, पीछे की winds को कोई रोकता नहीं है, because there is no eastern ghats. So उसका intensity of winds is up to deep. Plus Krishna Godavari delta है, so जब भी storm surge आता है, it can go much deeper inside the river के mouth के अंदर. सो जो हाई वेलोसिटी सी वेव्स है वो कृष्णा और गोदावरी के माउथ के अंदर इनसाइड तक दे कैन गो, बिकॉज दिस आर द टू बिगर रिवर. सो इसलिए द इफेक्ट उसका डिस्ट्रक्शन इज सीन मच इंटीरियर. एंड थर्ड, बिकॉज इट इज द डेल्टा, इट इज वेरी फर्टाइल, एंड बिकॉज इट इज वेरी फर्टाइल, इट इज वन ऑफ द डेंसली पॉपुलेटेड रीजन्स. सो इसलिए इफेक्ट ज़्यादा है. सो यू कैन नोट डाउन फॉर प्रीलिम्स, दैट इज coastal Andhra Pradesh, that is Krishna Godavari delta, and Mahanadi delta regions of Orissa, and Mahanadi delta region of Orissa. Will have greater effect of tropical cyclone. Mahanadi delta region of Orissa are thickly populated. Mahanadi delta regions are thickly populated. Don't write greater. Are thickly populated, and therefore the destruction is greater. Fine with this? So उसके साथ साथ मैप में देख लेना. Again, look at that map again. Sheveroy is Eastern Ghats or Western Ghats? Eastern Ghats. और Sheveroy is meeting which hill? नीचे नीलगिरी और अन्नामलाई. Nilgiri. So, because you should remember for Indian geography what is the basic difference between Eastern and Western Ghats. Western Ghats are straight, continuous, और Eastern Ghats इतने broken है, discontinuous है. एक पार्ट है शेवेराय तमिलनाडु में, जावड़ी तमिलनाडु में, आंध्रा में नल्लामलाई एंड पालकोंडा, उसके बाद बीच में गाया भी है और डायरेक्टली है इन ओडिशा एज गरजात हिल्स. सो व्हाई दे आर ब्रोकन? River erosion. They have been cut by rivers. Understanding this? So अभी के लिए सिर्फ इतना याद रखना, Western Ghats are continuous, Eastern Ghats are discontinuous. Eastern and Western Ghats meet at Nilgiris. Nilgiri is a part of Western Ghats. कौन सा part of Eastern Ghats meets the Nilgiris? Sheveroy Hills. लिखा है उधर Sheveroy Hills. Sheveroy Hills.
This is a part of
Eastern Ghats. So, Anaimudi. So, अभी सिर्फ मैप में इतना याद रखना ताकि इंडियन ज्योग्राफी में ये फिर से आएगा और डिटेल में आएगा कि कौन सा पीक, कौन सा फॉरेस्ट रिजर्व, कौन सा एनिमल, ये सब है. दैट इज डेल्टा. Godavari is delta, not estuary. Delta, estuary नहीं. Mouth of Godavari is bigger. You may have read somewhere very casually लिखा होगा estuary of river Godavari. Geography में estuary on the western coast. deltas on the eastern coast. You cannot call Godavari, हिंदू में आ जाएगा कभी कभी, but वो technically नहीं देख रहे, वो तो कैजुअली एस्चुरी एंड डेल्टा को मिक्स कर रहे हैं. सो डोंट गो बाय दैट वर्ड्स ओनली. गोदावरी डेल्टा, माउथ ऑफ गोदावरी डेल्टा इज वेरी बिग, ऐसे बोल सकते हो. तो दैट इज ईस्ट गोदावरी डिस्ट्रिक्ट एंड वेस्ट गोदावरी डिस्ट्रिक्ट, काकीनाडा वाला रीजन. सो दैट इज वेरी बिग. फ्लैट प्लेन्स है, इसलिए राइस कल्टिवेशन बहुत है, इसलिए एक्वाकल्चर बहुत है. फाइन विद दिस. सो वन लास्ट थिंग, लिखने की जरूरत नहीं, जस्ट लिसन टू मी. मैं इसका प्रिंट आउट दे दूंगा तुम्हें, क्योंकि एक क्वेश्चन आ चुका है और इतना स्पेसिफिक क्वेश्चन मेंस में फिर से नहीं आएगा. सो इसका प्रीलिम्स बेस्ड आ सकता है. दैट इज द नेमिंग ऑफ ट्रॉपिकल साइक्लोन. Why names? Effective disaster management. Why you need effective disaster management? Because more than one tropical cyclone can originate at the same time in the Bay of Bengal region. Second, the tropical cyclone does not have any fixed direction. It can change its path midway. Third, at the same time there can be more than one, kitna bhi, 10 bhi, 12 bhi tropical cyclones which are originating in Bay of Bengal as well as in the Arabian Sea. So if we do not give the name, and if there is a low pressure system which has developed near the coastal Orissa, there is a low pressure system which has developed near the Andaman Sea, and there is a low pressure system which has developed in the Arabian Sea region. So imagine कितना difficult हो जाएगा to tell the people. क्या बताओगे आप? एक low pressure system जो ओडिशा के पास develop हुआ है, वो, or there is a low pressure system developed near Orissa, it may turn into a tropical cyclone. Right now we have known that it is only a depression. This low pressure system is trying to go towards Andhra Pradesh. Now the news has come, a new low pressure center has developed over the Andaman Sea, which is also going to strike over Andhra Pradesh. And actually there is another third low pressure system which is developed in the Arabian Sea which may hit Gujarat. लोग सोचेंगे इतना confusion से अच्छा हम वो मर जाते, वो ठीक है. There is no need of going, that is away. So इतने low pressure system actually, so cyclone Gaza, cyclone Falin, cyclone Thane, proper नाम दिया है, cyclone Falin. सो आगे अब सोचते नहीं लोग कहाँ पे. साइक्लोन फालिन, आप दिल्ली में हो, अरे हमारे काम की न्यूज़ नहीं है, बट कोई उड़ीसा में, यस हमारे काम की न्यूज़ है. सो यू विल लिसन टू दैट. सो दैट इज व्हाट इज नोन एज एन इफेक्टिव डिजास्टर मैनेजमेंट. अंडरस्टैंडिंग दिस, सो यू शुड नो देन हाउ डिड द नेमिंग ऑकर्ड, हु स्टार्टेड द नेमिंग. दिस हैज बीन योर पास्ट 2015 का 250 मार्क्स का मेंस का क्वेश्चन. सो द नेमिंग ऑफ ट्रॉपिकल साइक्लोन, व्हाई वी डू प्रॉपर नेम्स, so that effective disaster management. This should be an introduction to the answer, because giving proper names makes communication easy. क्योंकि disaster management में सबसे पहले होता है effective communication, so that you have seen how effective is the communication. वो वीडियो देखने के बाद कोई रहेगा उस घर में नहीं, all will go away, क्योंकि उन्होंने दिखाया कि literally cars can float. नहीं तो क्या होता है, अरे अर्थक्वेक या कुछ भी, कुछ नहीं होगा यार, हमारे घर को कुछ नहीं होगा, क्या नहीं जाते, घर के अंदर बैठे रहेंगे. दिस इज आवर मेंटालिटी. हु विल लाइक टू गो, डिस्प्लेसमेंट किसको अच्छा लगता है. सो एज अ रिजल्ट ऑफ दिस, सो दिस आर द पॉइंट्स यू शुड कम. देन सेकंड, हिस्ट्री ऑफ नेमिंग. द नेमिंग ऑफ ट्रॉपिकल साइक्लोन्स स्टार्टेड इन ऑस्ट्रेलिया सबसे पहले, where a private news channel, radio news channel, used to name the tropical cyclones giving the names of the most corrupt politicians in Australia. So this is how the naming started. But that channel was shut down. Obvious है, politicians के नाम देंगे tropical cyclones को तो channel बंद होगा. So that channel was shut down. But the idea was picked up by US Naval Department of naming the tropical cyclone. क्योंकि hurricanes कहाँ stronger है? In the US. हमारे साइक्लोन्स आर नथिंग इन फ्रंट ऑफ हरिकेन्स. हरिकेन्स आर वेरी स्ट्रॉन्ग बिकॉज वहाँ पे वार्म करंट है, गल्फ स्ट्रीम, हीट ज़्यादा होता है. अंडरस्टैंडिंग, ओशनोग्राफी से रिलेट करो. सो एंड द US Navy officer wrote a book, one of the most famous novel known as The Storm, in which he took up this idea and in that book he had given the names of a tropical cyclones, जितने भी उसकी ex girlfriend की थी उन सब के नाम उसने tropical cyclones को दे दिए थे, all his ex girlfriend का names tropical. Therefore initially the tropical cyclones were given only female names. Understanding? Katrina, that is why Katrina, only female names were given. So understand this answer here. The names were given by this, the only females names were used. किसने शुरू किया नेमिंग? US वेदर डिपार्टमेंट ने. ये जो मैंने दिखाया है ये US गवर्नमेंट का वेबसाइट है, वेदर रिपोर्ट. ऐसे नहीं है कि कोई प्राइवेट चैनल का वेदर रिपोर्ट है. US वेदर डिपार्टमेंट. ये जितने भी मैंने आज आपको कोरियोलिस फोर्स और सबके वीडियो दिखाए वो UK का स्कूल एजुकेशन के लिए वीडियोस बनाए हैं UK गवर्नमेंट ने, so that people in the school can understand what is the Coriolis force, what is this force. School education के videos है UK government के. So they started naming, fine. But in 1980s, they started naming. This idea was picked up, not in 19. This idea was picked up by United WMO, that is the World Meteorological Organization, and they started naming the tropical cyclones. ये एक पॉइंट हो गया. नेक्स्ट थर्ड पॉइंट, बट इन 1980s increasing feminist movements objected to naming the tropical cyclone having only female names, and therefore in 1980s it was decided to use gender neutral names for the tropical cyclone. कोई भी हो सकता है, आदमी का भी और the females का भी, gender neutral names. Then comes the next point, how the naming is done. So WMO divides the world into different ocean basins. ये world है, this is North America, this is South America, this is Europe, this is Africa, this is India, Indian Ocean. कैसे different ocean basins? North Atlantic Basin, South Atlantic Basin, North Indian Ocean Basin, South Indian Ocean Basin, North Pacific Basin and South Pacific Basin, and the countries in that basin are arranged in alphabetical order. So जो country, for example, a country is in the North Atlantic Basin, there are some countries who are going to face tropical cyclone, not all the countries. Canada नहीं होगा उसमें, या इंडियन ओशन में नेपाल एंड भूटान नहीं होगा. यहाँ से प्रीलिम्स का एक फैक्ट शुरू हो जाता है, सो याद से रखना. So all the countries which are prone to tropical cyclone in that region, north में या south में, they are arranged in the alphabetical order. Now take up example of Indian Ocean. Alphabetical order में सबसे पहले A से कोई country है Indian Ocean region में? No. So the next country is Bangladesh. C से, D से, E से, F से. So the next country is India. उसके बाद उस इंडोनेशिया पैसिफिक ओशन ईस्ट की तरफ, इंडोनेशिया में नहीं. सो द कंट्रीज, बांग्लादेश के बाद म्यांमार, पाकिस्तान, थाईलैंड, श्रीलंका. ऐसे the countries will be arranged in an alphabetical order. So just remember, as of now, countries will be arranged in an alphabetical order. So all these countries will submit the list of names. Names कुछ भी हो सकता है. They will submit the list of 8 names. So इसने दिया 1, इसने दिया 2, इसने दिया 3, 4, 5, फिर से 6, ये कितने हो गए? So imagine that there are 4 countries. They will submit the names. कितने लिस्ट देंगे? 8 names. So the 4 into 8, 32 नाम्स देंगे. To whom? To WMO. And if a cyclone first originates anywhere in that region, किस country का नाम दिया जाएगा? A का. After, what is the name? Name will be given as 1, for example. इसने दिया 1 as a नाम, तो that will be used. So अगर इंडिया में कोई tropical cyclone आता है, even in this region or even in this region, but who is in the list? Bangladesh is in the list. So the name of Bangladesh will be chosen. श्रीलंका में कोई tropical cyclone आता है और इंडिया में कोई ट्रॉपिकल साइक्लोन आता है, थाईलैंड का नंबर था इसलिए थाईलैंड का नाम इज चोजन. सो ऐसा ये नहीं है कि जिस एरिया में ट्रॉपिकल साइक्लोन आता है दैट कंट्री विल बी गिविंग द नेम. इन द नॉर्थ इंडियन ओशन रीजन देयर आर 8 डिफरेंट कंट्रीज. दे सबमिटेड 64 नेम्स and alphabetically the names are taken. So first with the name of Bangladesh will be used. So cyclone Thane is a city in India. The cyclone Thane was submitted by India, but cyclone आया था ओमान में. Understanding this? So the names will be submitted and the names will be used. Fine, ये हो गया world level पे. कम थाने क्यों दिया था? थाने इसलिए दिया था बिकॉज उस साल सेंसस में थाने वॉज द मोस्ट पॉपुलेटेड डिस्ट्रिक्ट. सो क्यों दिया था वो सब छोड़ो, क्यों कुछ भी दे सकते हैं. सो फेताई क्यों दिया था, सिर्फ इतना याद रखना ओखी का मीनिंग क्या है, फेताई का मीनिंग क्या है. अब द नेमिंग ऑफ द ट्रॉपिकल साइक्लोन स्टार्टेड इन द वर्ल्ड प्रॉपरली फ्रॉम 1980s, but till 1999 the naming of tropical cyclone did not occur in Indian region, in the North Indian Ocean region. क्यों? हम झगड़ रहे थे, पाकिस्तान कौन सा नाम देगा, ये कौन सा नाम देगा. Understanding this, so there was no consensus to be met कि how they will be arranged. Pakistan was not ready to come in the group जहाँ पे इंडिया है. WM was saying कि ग्रुप में पूरे कंट्रीज आनी चाहिए, इंडिया के साथ हो या ना हो, साइक्लोन तो तुम्हें आएगा ही. सो यू हैव टू बी इन दैट ग्रुप. ऐसे सो ये छोटी छोटी चीज़ों से, इसलिए 1999 का जो साइक्लोन आया था उड़ीसा में, इट डज नॉट हैव एनी नेम. बट दैट टाइम वी रियलाइज द इम्पॉर्टेंस ऑफ डिजास्टर मैनेजमेंट व्हेन 1000 पीपल डाइड इन उड़ीसा बिकॉज ऑफ 10,000 वेर डिस्प्लेस्ड. 1000 वेर डाइड ऑफिशियली, अनऑफिशियली आई डोंट नो. Unofficially it is into 3, not 10,000. I guess so. So you can check that. 1,000 people or more than 1,000 people died in Orissa. Orissa alone. And why? Because we could not predict properly. और हमने नाम दिया super cyclone. So from the year 2000, देखो आंसर में इंडिया का भी लिखना पड़ेगा. The countries of the Indian Ocean region started naming the tropical cyclone. And they were arranged in the alphabetical order, starting with Bangladesh, ending with Thailand. ST. T पे end होता है. Which submits the list of 8 names which are gender neutral names. And then you can write any of the examples. Cyclone Okhi was named by this, Cyclone Fetai was named by this, etc. Fine? If a tropical cyclone causes too much of death and destruction, as a mark of respect to the people who have died, that name is dropped from the list. That name will not be used again. But if it does not causes a destruction, it can be reused again. The naming in the Indian Ocean is done by WMO's regional center, which is located in New Delhi. Understanding? ये भी लिखना है. कहाँ पे है? वर्ल्ड मेट्रोलॉजिकल ऑर्गेनाइजेशन का रीजनल सेंटर न्यू दिल्ली में. So that is the end of an answer. Getting it? So Katrina will never be used again. Florence will never be used again because they have caused large-scale death as the mark of the respect to the people who have died. Getting this? So this is how the naming is done. और 64 नाम हो गए ना उनके पास. तो 64 जब खत्म हो जाएगी लिस्ट तो नई लिस्ट भी यूज कर सकते हैं और नाम रिपीट भी कर सकते हैं. एक कंट्री 8 नाम देगी. सो टोटल कितने नाम हो गए? 64. और नाम कब देंगे? ओनली इफ इट इज साइक्लोन, मतलब ओनली इफ इट क्रॉसेस 120 किलोमीटर्स पर आवर. नाम तब तक नहीं देंगे. अंडरस्टैंडिंग दिस? सो this is what is the tropical cyclone. I am giving you one assignment. Note down the question. Compare and contrast. Compare and contrast. The tropical cyclone with extratropical cyclones. Tropical cyclones with extratropical cyclones. देयर इज नो वर्ड लिमिट, पहले जितने पॉइंट्स जनरेट कर सकते हो करो विथ एक्स्ट्रा ट्रॉपिकल साइक्लोन्स। एनसीईआरटी में है ये क्वेश्चन, यूपीएससी में भी 5 बार आया है ये क्वेश्चन, याद रखो। सो इसका मॉडल आंसर लिख के रखो, देयर इज नो वर्ड लिमिट। वाई? बिकॉज फर्स्ट यू जनरेट द पॉइंट्स, देन आई विल टेल यू हाउ द पॉइंट शुड बी अरेंज्ड। ये नहीं लिखना है एक नेचुरल डिजास्टर है दूसरा नेचुरल डिजास्टर नहीं है, एक बहुत ज़्यादा रेनफॉल करता है दूसरा रेनफॉल नहीं करता। प्रॉपर स्टार्ट विथ एरिया लैटिट्यूड्स, देन कम टू द प्रेशर सिस्टम, कम टू आइसोबार्स, कम टू द टेम्परेचर कि एक में टेम्परेचर डिफरेंस है बिकॉज उसमें फ्रंट्स है, एक में फ्रंट्स नहीं है। कम टू प्रेसिपिटेशन, कम टू विंड स्पीड, कम टू डायरेक्शन, and then talk about natural disaster. Geographical points we want, okay? So वो लास्ट में वही मैं कह रहा हूँ, डिस्ट्रक्शन मत लिखो नहीं तो स्कूल वाला आंसर, वो लास्ट का पॉइंट है। सो विल स्टार्ट विथ ओशनोग्राफी ऑन मंडे।